Hi, I'm Steve Brandt, and I work at CCT here at LSU, and I'm in the Cyber Infrastructure Development Group. And what I'd like to show you is a small research project that I have been carrying out with some students. It's called Ubiqis, and the idea is it stands for ubiquitous install. I have a poster over here, which I have used in the past. So the idea is that you want to use software on a variety of machines, a variety of different platforms, and there's a complicated procedure with installing it, with maintaining the installs, with maintaining dependency trees, and there are a number of different solutions in this space. The one that I want to show you is one that requires no configuration of dependencies that are explicit. Software installs occur transparently on demand, and so I think that these are some unique characteristics of this system. So let me show you how it works. So this is my little demo directory. I'll clean everything out of it. Okay, I've got a number of different files in here. First I'll show you Java. Now I've got a file called bar.java, and it is going to invoke it imports a package with this funny name, edu lsu cct ubiq3 underscore ts brandt v1 fib20 fib20. So, well, fib20 is the class name as well as the package name. Now it's a little bit long, but I think it's not quite unmanageable. And the nice thing about this length of package name is we can through an algorithm we can map it to a URL, and we can go to that location and fetch the package. And what we're going to do is we're going to do this automatically. And we're not going to do this by instrumenting Java, and we're not going to instrument the Java compiler. What we're doing instead is we're going to use a fuse file system to capture the requests for the files. I'm going to set the class path variable to include /mnt/ubiquis. Now what's going to happen is when I either compile or run Java, Java is going to look under the mnt ubiquis directory for a sequence of subdirectories finally culminating in fib20.class. And if and when it finds it, it will succeed in running or compiling. So these are all this is the Ubiqis cache, and these are all the different software packages it knows about. What I'm going to do is I'm going to clean out that cache. I'm going to remove some of those things it's installed, just so I can show it to you installing it automatically. So I've cleaned this out, and there's only a few things in here now, and none of the Fibonacci classes are in here. Now, let me just show you first of all the compilation step. So I'm going to go over, I'm going to type javic bar.java. It succeeded. If I go over here now and I type the find again, you'll see that fib20 has shown up in the list. It's now there. Above here we couldn't see it. Okay, that's because in order for the compiler to succeed, it had to link in fib20.java. Now fib20 stands for Fibonacci 20, and the way this is going to work, the logic of this class, it's very small. It looks something like this. The idea is a Fibonacci number is equal to the sum of the two previous numbers in the series. So what I'm going to do is I'm going to import a package for 19 and 18, and then I'm going to get the two values and add them together and return them. That's going to show you the value. Now this is a stupid way to calculate the Fibonacci sequence, obviously, but the point of it is I've created a huge dependency tree where 20 depends on 18 and 19, and 19 depends on 18 and 17. And I haven't configured this dependency anywhere. It's just implicit in the source code. And when I go to use one of these packages, as each component is needed, the fuse file system is going to detect it and load it. So now what I will do is I will run this class. Now unlike the compilation step, which only needed to bring in fib20 because that was the only immediate dependence, the run is going to have to bring in everything. So here I go, Java bar. It'll take a little while because it has to go out to the web and fetch every one of those classes. Okay, there it is. There's the answer, 6,765. Okay, so it did all that while we waited. You might wonder what happens if one of those packages goes away. For example, the company that was offering something through the Ubiquis framework folds and their website goes down, or somebody simply moves the files out of the way. Well, we have an answer for that. What we have is a peer-to-peer server called a registrar, which sits at each Ubiquis installation, and it can serve any Ubiquis packages that are currently on a system to another system. So what I'm going to do is I'm going to show you, I have another machine here. This is a virtual machine. And so it's completely separate install. This is a different operating system even. And it has also got a Ubiquis instance running. Okay, and it's got all the Fibonacci's installed, as you can see. I'm going to clean them out. Now I'm going to do something else. Now all these packages are being offered by a host called is. What I'm going to do is I'm going to go over to is. See, there's the directory they're being hosted in. I'm going to move that directory to something else. So now all attempts to fetch the packages will fail if they go directly to the website. Now what I'm going to show you is we're going to load this from another machine with the where the server is no longer offering the files. I've moved the Fibonacci files out of the way on the server that originally offered them. And what's going to happen is from this other server, it's going to try simultaneously to load from the vendor server and from other servers in the peer-to-peer network that it knows about, and it will use whichever result it gets fastest. In this case, there's only going to be one result coming back, and that's going to be over the peer-to-peer. And this is the log for the peer-to-peer server. Okay, so the compilation succeeded. Next, I'm going to show you, we're going to run the file. And you can see over here, it's finding keys and finding files and loading them. It's sucking them in all through the peer-to-peer network. It's got to grab all 20 packages. And it succeeds and gives us the answer again.